Welcome, fellow seekers of truth and occasional absurdity. Today we're diving into the glorious annals of scientific history, not to celebrate triumphs, but to revel in the magnificent blunders. Because sometimes to get things spectacularly right, you first have to get them spectacularly, hilariously wrong. Science, you see, isn't a rigid dogma. It's a perpetual work in progress, a cosmic game of guess and check. And these 5 instances prove that even the brightest minds can occasionally wander down a very scenic, but ultimately incorrect path. But here's the kicker. Those wrong turns often paved the way for groundbreaking discoveries. Let's start with a classic, a real crowd pleaser. The idea that our world was a giant cosmic pancake. For millennia, many cultures believed the Earth was flat, often covered by a dome-like sky. It seemed perfectly logical from our limited vantage point. Then came the more sophisticated geocentric model, championed by ancient Greek astronomers like Ptolemy. This theory placed Earth firmly at the center of the universe with everything else, including the sun and planets, dutifully orbiting us. It was an elegant, if self-centered explanation. This geocentric view dominated scientific thought for over 400 years. It was so ingrained that challenging it was considered heresy, both scientific and religious. Imagine being told the sun revolves around you every day. It's quite the ego boost. The irony, of course, is that early Greek thinkers like Eratosthenes had already calculated Earth's circumference with remarkable accuracy, proving its spherical nature. Yet, the flat Earth notion persisted in popular imagination, and the geocentric model held sway in academia. It took the likes of Copernicus, Galileo, and Kepler to finally shift our perspective literally to a heliocentric view. Next up, let's talk about fire, that mesmerizing dance of destruction and warmth. For centuries, scientists struggled to understand what made things burn. Their best guess? Phlogiston. This invisible, odorless, weightless substance was supposedly contained within all combustible materials. When something burned, it released its phlogiston into the air, leaving behind a dephlogisticated residue like ash. Metals, for instance, were thought to be compounds of phlogiston and their respective calyxes. Heating a calyx with charcoal, rich in phlogiston, would restore the metal. It was a beautifully intricate theory that explained many observations of combustion and rusting. It even accounted for why a candle eventually goes out in a sealed jar. The air became saturated with phlogiston, unable to absorb anymore. It made perfect sense if you didn't look too closely. The irony arrived with Antoine Lavoisier in the late 18th century. He meticulously weighed substances before and after burning, demonstrating that combustion actually increased mass, not decreased it. He showed that burning involved combining with something from the air which he named oxygen. Phlogiston, the invisible fire stuff, was unceremoniously debunked, replaced by a much more accurate understanding of chemical reactions. Prepare for a tale of maggots, mice, and mistaken assumptions. For millennia, people believed in spontaneous generation, the idea that living organisms could arise from non-living matter. Maggots appeared on rotting meat, mice sprang from dirty rags and grain, and fleas materialized from dust. Aristotle himself championed this idea, observing that aphids seemed to form from dew on plants. It was a convenient explanation for the sudden appearance of life, especially when you didn't have microscopes or a firm grasp of microbiology. Why bother with parents when your dinner could just become alive? This belief persisted for centuries, a testament to the power of seemingly obvious observation. If you saw maggots on meat and you didn't see flies lay eggs, what else could you conclude? It was a logical leap, albeit a wrong one. The irony is that simple experiments began to chip away at this notion. Francesco Redi, in the 17th century, showed that maggots only appeared on meat exposed to flies. But it took Louis Pasteur in the mid-19th century, with his famous swan neck flask experiments, to definitively prove that life only comes from pre-existing life. No more magical mice from laundry baskets, just good old-fashioned reproduction. Imagine light, traveling across the vast emptiness of space. If light was a wave like sound or water ripples, it needed a medium to travel through, right? That's where the luminiferous ether came in. Scientists in the 19th century hypothesized this invisible, undetectable substance permeated all of space. This ether was thought to be incredibly rigid, yet completely transparent and frictionless, allowing planets to move through it unimpeded. It was the cosmic jello through which light waves undulated, reaching our eyes from distant stars. It was a brilliant theoretical construct, designed to make the universe behave according to the known laws of physics. Scientists even designed elaborate experiments like the Michelson-Morley experiment to detect Earth's motion through this ether. They expected to find variations in the speed of light depending on our planet's direction of travel. The results? A resounding null. No ether wind was detected. The irony is that the ether, this elegant solution to a perceived problem, simply didn't exist. Albert Einstein, with his theory of special relativity in 1905, elegantly demonstrated that light doesn't need a medium. Its speed is constant for all observers, regardless of their motion. The ether, once a cornerstone of physics, vanished into thin air, leaving behind a much more beautiful and stranger universe. Finally, let's talk about sickness. Before germ theory, what did people think caused diseases like cholera, the plague, or malaria? Bad air, of course. This was the miasma theory, which held that diseases were caused by bad air or miasma, emanating from decaying organic matter, swamps, or poor sanitation. It made a certain kind of sense. Areas with poor hygiene often had more disease, and they certainly smelled bad. So the logical conclusion was that the foul odors themselves were the culprits. People wore perfumed masks, avoided bad air, and tried to air out sick rooms. This theory influenced public health measures for centuries. Cities tried to improve ventilation and remove obvious sources of stench. While these efforts sometimes inadvertently helped by improving sanitation, the underlying reason was completely wrong. They were fighting the smell, not the invisible enemy. The irony is that while they were busy holding their noses, tiny, unseen organisms were doing the real damage. It took pioneers like John Snow, who traced a cholera outbreak to a contaminated water pump, and later Louis Pasteur and Robert Koch, to establish the germ theory of disease. Suddenly, the enemy wasn't a smell, but microscopic invaders. This shift revolutionized medicine and public health, saving countless lives. So, there you have it. 5 times science took a detour, sometimes for centuries, before finding the right path. But here's the profound lesson. These wrong theories weren't failures, they were crucial stepping stones. They provided frameworks for understanding, even if flawed, and spurred the very experiments that eventually disproved them. The beauty of science isn't in its infallibility, but in its relentless pursuit of truth, its willingness to question, to test, and most importantly, to self-correct. So, the next time someone says science got it wrong, remember, that's not a weakness, it's its greatest strength. It means we're always learning, always evolving, and always getting a little bit closer to understanding the magnificent, bewildering universe we inhabit. If you enjoyed this video, please like, share, and subscribe to support our channel. Your support helps us create more fun, educational, and inspiring content every week.